Hello, and welcome to your Classes and Object-Oriented lecture. Now, I hate that we have to leave this to the very last lecture of the year, but we want to introduce a little bit about classes and object-oriented programming, because if you continue on to the next class, which is all about object-oriented programming, I think these concepts will be pretty useful, and as usual, everything in Python is just a smidge simpler than it is in other languages, so it might be nice to learn it here. So today we're mainly going to talk about classes. Classes in Python are basically a way to make a template that can make an object. You can think of it as like a cookie cutter or a blueprint. It's not the object itself, but it contains instructions on how to make an object. For instance, a cookie cutter can take itself and make multiple cookies, and a blueprint can take it, you can make multiple buildings with it. That's the same for a class in Python. Remember how I've said sprinkled throughout the semester that everything in Python is an object? Well, classes are how we create objects. For instance, we have things like lists and dictionaries, but now we're going to create our own classes. These classes that we build have two major things that we're going to talk about. And trust me, we're only skimming the surface on classes here. There's so much more to know. The two main things that classes have are attributes and methods. Attributes are basically a way that a class can store data about itself, like a list could store its own length, and a method is a function that belongs specifically to this class. Maybe this sounds familiar because we've talked about things like list methods or string methods or dictionary methods. But now that we're creating our own classes, we're going to write our own methods. Okay, I'm going to go through all of this via the slides and explain some of the conceptual stuff to you, but don't worry, we're going to go to Atom soon and write all of this stuff out for ourselves. So the way that we create a class actually looks a lot like how we create a function. We're going to use the keyword class though, and then the name of the class. Indented underneath the class is all of the stuff that we want the class to do. This is going to include defining its attributes as well as defining its methods. Now, class methods, like I said, are basically functions that work specifically for this class that we're building. And the one type that we pretty much always define is an init method. I mentioned at the very beginning of this semester when we talked about naming variables and things like that while you can start things with underscores, it's actually better practice not to. And this is one of the reasons. Special functions in Python and special variables often start with underscores. For instance, this init function starts with 2 underscores and ends with 2 underscores, and we have to name it exactly this. This means something very special to Python. It tells Python what to do when creating an object of the class that you're writing. For instance, in this code, you can see we're creating a class called square, which is going to represent like the shape square. The init function will run, it's a constructor, it'll run anytime that we have a square and we create one. So for instance, this is our very simple square class definition, and here on line 10, we're actually creating a square using this class. We're giving it the side length 10. Now, the init function is what creates the class instance. Remember I said that classes are basically like cookie cutters or blueprints? Well, an instance is basically what those things create, either an actual cookie or a building in the case of a blueprint. So when we have this blueprint or this class for square, we can use it to create an instance, a particular square. In this case, I'm creating a square, I'm giving it the length of side 10, and I'm calling it Bob because I'm storing it in the variable Bob. All right, that was a lot of information. Let's go through that step by step. So looking at this init function, it looks a lot like a regular function definition, except for the fact that it has weird 2 underscores at the beginning and end. Now it takes in 2 arguments, self and side. Side seems pretty self-explanatory. It's just the length of the side of the square. The self argument, that's an entirely different thing. Let's go ahead and talk about that. So the nice thing about a class is that it has, as I said, attributes and methods. If you think back to the last lecture we did with grouped functions, what we did was we wrote a bunch of functions that took in a dictionary and then took in maybe some other arguments and did some stuff to the dictionary. Well, we're basically using classes to do exactly that, but without having to have a dictionary. A class has access to its own attributes. So instead of a dictionary of values, we actually just have values that are inherently stored in the class, and we can reference them anytime we want. All of the functions, all of the methods that we define within this class are going to have access to those values. Let's go back to that code picture. So here you can see that we have two types of attributes. First, you can see we have self.sideLength, and we set it equal to whatever the side length is. This is called an instance attribute. It can be different between different instances of the class object. For instance, if I created another square, its side length might be 2. That's totally fine. An instance attribute can be different between different instances of the object. The way that we set them is we say this keyword self dot the name of the attribute, and then set them equal to whatever we want. We're often doing this inside the init function because that's what runs when we create one of the class objects, but technically it can happen elsewhere as well. So in this line on line 7, we're saying self, which references the specific square we're talking about, right? This is just a cookie cutter. It can make multiple squares. It can make multiple objects. Self is basically saying, hey, for this particular square, grab its side length and set it equal to whatever we put there. The other type of attribute a class can have is something called a class attribute. We've defined one on line 5 here. We said shape equals square. A class attribute is something that is not different between different instances of the object. For instance, a square could have different side lengths depending on the square, but the shape of it will always be a square. As I said, we usually define instance attributes inside the init function, though not always, and we often set class attributes outside, above the. Both of these things are attributes of the class, so anytime we use the class, we can reference these values. Let's go to Atom and put this square code to use. All right, so that was a lot of detail. Let's start building this class on our own so we can see how it works. Again, to build a class, we first start off with the class keyword. Then we type the name of the class. Now, it doesn't have to be, but typically the first letter of the class will be capitalized. This is just best practices and something that people do a lot when they're writing Python. Python won't throw an error if you give it a lowercase letter, but you probably want to give it an uppercase letter just to be consistent with how professional people write their Python code. So we're going to say class square. And then we're going to go ahead and set any of the class attributes that we want. So this is something that cannot be different between the different squares we might create with this class. So for instance, I'm going to say shape equals square because no matter what, a square is going to be a square. And then I'm also going to add one. I'm going to call side count equals 4 because no matter what, every square is going to have 4 sides. So these two things are class attributes. They are the same for every single square that we create. Next, let's define our init function. I'm going to say def underscore underscore init underscore underscore and open parentheses. So this looks exactly like a function definition. Now we're going to put 2 arguments inside this function. Every single function that is a class method is going to take first the argument self. As I mentioned before, right, the class square can be used to make multiple squares. We can make a square with 4 sides, one with, with 4-inch long sides, with 3-inch long sides, etc. And so self is basically saying, hey, when I'm asking you for this, I'm asking for the specific instance, the value for the specific instance that I'm creating. So we're always going to put self, and then the second thing is what information do I need to create this object? Well, for a square, all we really need to know is how long its sides are. So I'm going to say side, and that's going to be an integer saying how long the side of the square is. Now, inside the init function, you have to ask yourself, okay, what do I want to run when I create a new square? Well, I want to set its side length, so self.side length. I want to set its side length to be whatever the person put when creating the square. Then I'm going to print, hello there, I am a square. It's good to be alive. All right. So now we have a functioning init statement. We have our class attribute, shape, and side count, and we have our instance attribute side length, which is going to be whatever we set it to be. Now let's see how this works if we wanted to, for instance, create a square. All right, so let's create our first square. We're going to say Bob. We're going to store our square in the variable Bob. Bob equals square, and we are going to give it any of the arguments besides self that are needed by the init function. I'll explain this in a second, but just remember we don't need to give it an argument for self. So side, let's say this has a side length of 4. So we're going to create a square with a side length of 4. Let's go ahead and comment out this code and run. We'll say Python 3 classes dot p blank. Okay. So you can see there, you can say, hello there, I am a square, it is good to be alive. Now remember, every time we create a class object, the init function is going to run. And so that's why we saw this print statement, hello there, I am a square, it is good to be alive. It's because we created a single square. Now, say I wanted to access some of this square's attributes. Say I forgot how long the sides were and I need to print that out. I could say print bob dot side length. Since squares have an instance attribute called side length, I can go ahead and access that by saying the object, the square object, dot the attribute that I want. Notice there's no parentheses after this. That's because this is an attribute, not a function. So we don't have to put parentheses after it. So let's go ahead and save that and print it out. And you can see that when we say Bob, which is our square with side length 4, when we print out bob.sidelength, it prints out 4. So you can see how it's super convenient that our object has all of this information inside of it. Instead of a dictionary, we can just use attributes. Similarly, we can grab class attributes. We can say print bob.shape. Maybe we forgot what shape Bob is. Again, no parentheses after this because it is an attribute, not a function. And we're going to save and we're going to run, and you can see that Bob is a square. Now remember, our class is just a cookie cutter or a blueprint, so we can create multiple squares using this class. Let's create one called Jim, and we'll say Jim equals square and have a length of side 7. So then we're going to create Bob that's a square and Jim that's a square. Jim is going to have side length 7, whereas Bob, as we know, has a side length of 4. So let's go ahead and run this. Awesome. So you can see when we run through our code, we've defined our class, and this is sort of like a function, right? When you define the class, nothing happens, but it's like instructions for what to do if you ask Python to use it later. So when we ran through this, we created a square Bob. We printed out, hello there, I'm a square, it's good to be alive, because when Bob was created, this init function ran. Then we went ahead and printed out Bob's side length, which is 4, and bob.shape, which is, of course, square. Then we created a new square object. We called it Jim, we put it in the variable Jim, and because we created a new square, of course, this init ran and printed out, hello, I am a square, it is good to be alive. All right, that's enough about defining these. Let's go ahead and go back to our lecture slides and see how we can create class methods. Okay, let's talk about methods. So we've already talked about one type of method that we put in our class definition, and that's init. And we know that that runs whenever we create a new class object. But that's not the only type of method that we can have. We can have general instance methods. These are also functions that are defined within the class and that only work for that specific class, but they can do anything. Init has to do its specific thing of constructing a new class object, but instance methods can just be whatever you need them to be. For instance, in this example where we created the square class, we have this instance method called area. Area takes in an argument self. Remember, self is basically how Python knows to refer to all of the attributes in the class so that we can actually access them and use them. For instance, having self allows us to access the side length and the shape of our class object. So for area, we know that the area of a square is the side length squared. So we're going to define this class method, or this instance method, to be def area, just like a regular function. It's always going to take in self. Any instance method is going to take in self as an argument, and then it can take in more arguments, but doesn't have to. This one doesn't need to. And we're going to say return self.sideLength squared. Because this is an instance method that took in self, we can access self.sideLength, which will basically say for this particular square, whatever their side length is, return that number squared, which is of course the area of the square. Remember, the cool thing about classes is that they have all of these attributes that we can access, and they have all these methods that we can use. And remember, our instance methods can access both class attributes and instance attributes. So for example, if we wanted to write a new function, a new instance method called perimeter, we could take in self as our only argument, and we could return the number of sides, so this is a class attribute, times the side length, which is an instance attribute because it can be different depending on the instance. All right, so let's go ahead and add those instance methods that we just talked about to our actual class. First, we'll define the area method. We'll say def area. Again, this part looks pretty similar to defining a regular function. And then remember that all of our instance methods must take in the argument self. So then we're going to return self.sideLength squared. So notice we can return things with instance methods. This basically means that if we called, for instance, bob.area, notice the parentheses because this is a method, not an attribute, we could basically store the result there. We could say a equals bob.area. In fact, let's go ahead and do that. Okay, so we went ahead and we ran it and we stored it. I should probably print it, so let's go ahead and print A. So when we run this, you can see that the area was returned, stored in the variable A, and then printed. And we know that Bob's area is 16 because his side length is 4. Now let's define the perimeter method. So we're going to say def perimeter. There we go. And again, we're going to take in self as an argument. And then we're going to say return self.sideCount. Again, this is a class attribute times self.sideLength. This will give us the perimeter of the square. So again, we could say P equals bob.perimeter. There we go. And then let's go ahead and print P. All right, so you can see that just like the area, the perimeter is 16 because we have 4 sides and they're each 4 long. Now, notice something interesting. When I was calling these class or instance methods, did I give it any arguments? No, I ran them completely empty, which is interesting because when we define them, they have an argument self. Well, what's actually happening is that when we say object dot, this is basically telling the function what self is. Bob is self. Bob is the instance that we're currently working with, and therefore we don't need to put it as an argument into the function. However, when we have other arguments besides self, like in the init function where we have the argument side, we do have to put that in there. So you basically say, give it a value for every argument that is not self, because we already know what self is by using dot notation. All right, let's define one more instance method for squares. We're gonna say def scale, there we go, scale size, and we're gonna take in self. So this is basically going to change the size of the square. So actually we need one more argument, which is the scalar, like how much are we scaling the side by? And so what we're going to do is basically say our square is 3 long on each side. If we scale that by 2, then each side is now going to be 6 long. So when we call this, we're going to say self.sideLength equals, and actually we could do it shortcut, times equals scalar. So whatever scalar, there we go. So whatever the side length was before, we are going to multiply it by the scalar, and then that's going to remain changed. Remember, the cool thing here is that classes and their their methods have access to the attributes of that class. So instead of having to return something and store it or something annoying like that, we can go ahead and just set it here, because every single method has access to both read and change the different class attributes. Okay, so let's go ahead and scale Bob. So I'm going to say bob.scale size 2. So Bob's sides used to be 4 units long, and now they should be 8 units long. To check it out, let's say print Bob dot side length and see if it changed. All right, we're going to go ahead and run this, and you can see, sure enough, Bob's new side length is 8 because we scaled it up by 2. Again, note the difference between when we call a method, we use parentheses because it's a function, and when we're accessing an attribute, we just say dot and the name of the attribute. Notice that scale size doesn't return anything. All it's doing is changing an attribute about the square, and that's it. We didn't need to store the new side length and create a new class object with it. All we had to do was call the function, and because it has access to all the attributes, it just changed them. All right, let's go ahead and do one more quick example of classes. And in fact, what we're going to do is we're going to take that student example from the grouped dictionaries lecture, and we're going to go ahead and turn that into a class, because really all those grouped dictionary exercises we did were just kind of doing classes, but less efficiently. So I copied the instructions here, and then I went ahead and copied all of the code that we wrote in the last lecture about that student dictionary and all those functions. Let's turn these into a class. So first of all, because a class has attributes, we no longer need this dictionary. That's all going to be a part of the class. So let's say class student, and we're going to have a bunch of attributes. Let's decide if any of these should be class attributes or if they're all instance attributes. So we have name, age, major, minor, classes, current, classes, all, clear status. So in my opinion, all of these should be instance attributes because they could be different for every single student or every single instance of this student class that we create. So instead of having any class attributes, I'm just going to start with the init statement. I'm going to say def underscore underscore init underscore underscore, and again, always self as an argument. But now I'm going to have a ton of arguments to build a student object. I need their name, I need their age, I need their major, I need their minor, I need their classes current. Now, I don't actually need their classes all or their clear status because we can just set those as we go, but these are the pieces of information that I need to create a new student object. Now, inside, basically what I need to do is think, okay, when I create a new student object, what do I want to run? Okay, well, I probably want to set all of those instance attributes, and I'm going to copy and paste them here. So you can see that we're setting name, major, minor, classes, current, classes all is blank, and clear status at the moment is not clear. So this basically replaces our need for this dictionary. Classes store their own attributes and information, so no need for that anymore. Last but not least, since it's an init statement, let's say print welcome to Chapman plus self.name. So this will just basically print out a welcome statement anytime we create a student object. All right, now it is time to turn all of these functions into instance methods. I'm going to go ahead and delete all of this lines of code that we have that is like calling the functions. And then, last but not least, I'm going to go ahead and highlight all of this and indent it under our class because that's exactly what we need it to do if we want these to be instance methods. All right, so how can we change these to be instance methods instead of just regular functions that worked on a dictionary? So the first thing is that we don't have a dictionary anymore. Remember, classes store their own attributes, so it's really nice that they basically have all that information inherently. So instead of taking in S, a dictionary, we can just change all of these to self. So I'm going to go ahead and do that. Self, 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 self. Okay, and now let's think a little bit about what we have to add in order to change these to be instance methods. Oh, one thing I forgot, self.age equals age. There we go, that would have been bad. All right, so we're gonna go ahead and look at this rename function. Now, because we don't have a dictionary anymore, instead of saying S, the dictionary, bracket the key name, we're just gonna grab the attribute name. So we're gonna say self.name, and that is still gonna be equal to new name. Similarly, for end semester, we're going to say self.classes all and self, self.classes current, and then self.classes current. So we're doing the exact same thing, but we're using class attributes instead of accessing a dictionary. Similarly, I'm going to say self.major. I'm going to say self.minor. Again, attribute instead of from the dictionary. And then we'll say self.clear status. And again, self.clear status. Beautiful. Okay, so with just a couple of changes, we change those grouped dictionary functions into a class. And now that we have our class definition, we can create a class instance. Now remember, we need to give it the name, age, major, minor, classes current whenever we create a new student object. So I can say, for instance, John equals student, the name of the class, and then any of the init arguments except for self. Remember, we know what self is because of the dot notation later on, so we don't need to give it that. But we do need to give it name, age, major, minor, classes current. So we'll say name, John, age, 21. Major is electrical engineering. Minor is data analytics. And their current classes, let's just say for some reason they're only taking CPSC 230. Okay, so we are creating an instance of the student class. The student's name is John, they're 21, electrical engineering major, data analytics minor, and their only class for some reason this semester is CPSC 230. Now, because we created John, we can access any of their attributes or call any of the instance methods. So I can say John.name, and I could print that out if I wanted to. Print, there we go, print John.name. Could also print John, oops, gotta spell that right, .major. I can access basically any of the attributes from John that I need. Let's go ahead and change John's COVID clear status. So I'm gonna say John.COVID clear, and excuse me, this takes the argument survey. Remember, self we know because of this dot notation, but survey will say equals false. This is because John isn't feeling very well. And then we're going to go ahead and say print John, John.clear status. Because remember, COVID clear, the method changes your clear status based on whether you feel sick or not. And so we expect this to now be not clear because John isn't feeling well. All right, let's go ahead and save, comment out our old code, and run. Okay, so you can see when we created the object, the student object, John, on line 91, this welcome to Chapman, John, printed out. Why? Because it's in the init statement. Remember, anytime we create an instance of an object, we do everything in the init statement, including print out welcome to Chapman. Next, we printed John's name and major, which are both attributes of the student object. And then we went ahead and changed John's COVID clear status. Because his survey was false, that then changed his clear status to be not clear. All right, that was a lot of information, but hopefully you have a little bit of a better understanding of what classes are in Python and how we can make our own. That's all I have for you. I will see you next time.